Hello, my name is Samuel Flores, and I work at the Department of Animal Genetics at the Swedish University of Agricultural Sciences. And you are very welcome to your lesson on containers using Docker. Your application along with all its libraries, along with something that's kind of like it's the operating system you want. I'm going to explain to you why I'm not saying it's exactly an operating system, but in any case, it's as the word says, it's a basic contained unit that does everything you want, and it works like magic on whatever system your user happens to have. So you don't have to worry about, do they have the libraries, what version of their operating system are they running, things like that. It's all like to you. You are giving them everything they need in terms of the environment. You might be asking yourself, okay, wait a minute. I think I've heard about this. This is a virtual machine. Well, no, it's not a virtual machine. They're quite different. And so we're going to go through the differences between a virtual machine and container. So first, there's this concept of virtualization, right? So in a virtual machine, you have your host hardware, and it's got all the hardware on it has interfaces. And on the hardware, there's something running called hypervisor, and it has direct access to the hardware, but then it presents a virtualized interface to the hardware, which can then be seen by a guest operating system, right? So there's a virtual machine. It's got a guest operating system. It has access to what it thinks are your hard drive, your memory, everything else. And as far as it knows, it's the real hardware, but it's actually looking at a virtualized interface. So the virtualization is at the hardware level. A container is very different. Here, your host hardware has a host operating system on top of it. And on top of that, there's this Docker, this container engine, which has access to the host operating system's kernel and uses it to do all tasks it needs. But then it presents an interface to that kernel that looks like whatever interface you want. Like it could give let's say, a Ubuntu interface, and your apps are running on this, and you put your libs on it, and everything looks just like Ubuntu. But what you don't know is you don't actually have an Ubuntu kernel. You're relying on the host operating system to provide that kernel. So this is called this is operating system virtualization. And then onto the guest OS. So as we mentioned, a virtual machine will have a full operating system. Full operating system installed, right? A container will have some sort of partial operating system. It's not really an operating system. It's just an interface that's taking advantage of this kernel, which is being facilitated by the container engine. And then so this might already start to give you a hint as to what I'm going to say about and the next point, which is about isolation. So your virtual machine is going to give you full isolation. It's maybe not impossible, but very difficult for your guest operating system or any of the apps that are running there to interfere, crosstalk with other virtual machines or with the host operating system. And a container, since it's sharing the kernel of the host operating system, maybe it's not full, but I would say it's pretty good. Like I've personally never had a problem with the container interfering with any other container. But you should know it's not exactly quite as airtight isolation as you would get with a virtual machine. Okay, so what does this stack look like? In the case of a virtual machine, you have, as I said, the hardware. And then on top of the hardware, you have this thing called the hypervisor, which again, its job is to have direct access to the hardware, but presents a virtualized interface of the hardware to your guest operating system. And maybe you have like guest operating system number 1, and then you can have a separate virtual machine with a guest operating system number 2, and so on. And then each of the, these are 2 virtual machines, right? So each of these virtual machines would then have, things like its libraries and its apps, right? And your guests, likewise, your second virtual machine might also have its own libraries and its own apps. Okay, so in a container, by contrast, so you of course have the same physical hardware for the host system, but then you have on top of that your host operating system, right? So for example, I'm doing this on a Mac laptop, and so my host operating system is Mac OS, right? And on top of that, you're going to have some sort of container engine. And that's again what's virtualizing the host operating system. Oh, sorry, I'm blocking that with myself. But there's a hardware and this host operating system, and on top of that, there's a container engine. The container engine is looking at your host operating system, looking at its kernel, and calling its kernel directly, but then presenting an interface to your container that looks like whatever operating system you want, right? So maybe, like I say, the container might have in it or Ubuntu or Windows or something. So inside that container, you might have a container number 1, and it would have some libraries, right? Typically, you just have only libraries you need, and you might have another container that has some different libraries, and then you would have your app, whatever app you want to distribute. You could have another container running that has some different app, right? So as you can see, that's quite a what something that looks superficially quite similar turns out to be interacting with the host hardware in a very different way. And what you gain by not having the container, not having this whole guest operating system, is that it loads up super fast, and then you can kill it super fast, and it's much lighter than a virtual machine. And again, the only real price you pay is that your isolation is maybe not quite as good. But again, in my personal experience, it's just never been a problem. And we're going to see that there are actually several ways you can do containerization. Here we're focusing on Docker. So, what is Docker? Well, I've already told you quite a bit about containerization in general. So this one advantage of Docker is that it is open source, and if you're in this course, then you're probably already convinced of the advantages of open source. I mean, it means that there's a community that's out there developing and improving it. It means you know what's in it. You know that it's going to be there many years from now. Docker enables to build, deploy, run, and let's see, manage containers. it allows for automated creation. So there's something called the Docker file, which is basically a script which will build your entire container. I use it for MMB, my code. It makes it very kind of maintainable, and you're able to do things like set it so that it rebuilds the entire image every time you post an update to GitHub. That's something that's actually gotten harder to do as a non-paying private user. But at any rate, it does have the Docker script which can run on your computer. There are other ways to build your Docker image, and you can clone an existing image and modify it and then save it. Let's see. Supports versioning. And so this means that's when you make a modification to your container, you can save it and then post it to a repository or a registry, as Docker likes to call them. And you can have tags which say which version it is, right? So you can have like numbered versions if you want, or you can have names. Basically, you can do whatever you want in terms of how you want to keep track of your versions. And there's also a version called latest, which is whatever you posted last. Let's see, it allows for reuse. So as I might have alluded earlier, you can take an existing image that does most of the things you want and just make a small tweak to it and save it separately to your own repository or, again, registry. And then other people can likewise download your image and make changes to it and save it either locally or on their own registry or repo. And regarding these repos, these can be shared. So it's a lot like GitHub, which you're already familiar with in this course. There's DockerHub, which lets you not only store and manage your own images, but also distribute them to others. Right, so somebody can go to your repo in DockerHub and look at all the images you have on there and decide which one they might find useful. So why should you use Docker? Well, you've already gone through some of the reasons. For instance, abstraction. And we said that abstraction means that you don't have to worry about about the environment. Like you can create a special environment for every single application or program that you want to run together with this sort of operating system and libraries. So you can deploy it on basically more or less any system. With very little in terms of installation issues. We also have this a lot more control, granularity of control, granular control. And so what that means is that we can control each application even better than we could if it were installed locally, or in a conventional way. So, for instance, we can control how much memory the Docker image can use. Very often you have a pipeline, and one part of your program maybe requires a large amount of memory, and maybe it works fine in your system, but when your user goes and uses it, then it just crashes on that part, and that can be kind of frustrating to deal with. So one way to deal with it is to limit the amount of memory that each Docker image can use. You can also limit the number of CPU cores, and you can even limit the amount of time that it runs. So that sort of that sort of control can be quite helpful. Then, of course, you have your available templates. For instance, if you say, "Oh, I want to, start with let's say an Ubuntu that already has Python 3 installed on it," right? So you just go find an image that has Python 3 on it, and then add your application on top of that, or you can have maybe some even much more developed environment that you've built for yourself. Like, for example, for MMB, I have all sorts of libraries that I know I need, and maybe text editors and so on, and sometimes I make some completely unrelated a Docker image, but I just happen to be already comfortable with this setup that I've already made, and so I grab that as a template, and then add my whatever applications I want onto that. Maybe that wouldn't be the most efficient thing if I wanted to distribute it to a bunch of people, but if it's something for my own purposes, I think it's perfectly reasonable. And then lastly, again, there's distribution. So you can just make a public image on your on DockerHub, and as mentioned, anybody in the world can go grab it and use it, modify it, do whatever they want with it. Okay, so how do we get started with Docker? So for in the case of Mac and Windows, there are some easy installers. And actually, this computer has just been wiped, so I actually don't have Docker installed on it, which is kind of fortuitous. So I'm going to go ahead and try to install it now. And so let's download. So we go over here to docker.com, and you'll find whatever installer you need. So in my case, I have a Mac with Apple Silicon, and so I'm going to download that installer. If it happens to be on Ubuntu, then you would use apt, right? And it's a couple of extra steps compared to doing it on Windows or Mac, but it's actually not hard. And then you just have to make sure that your daemon is running. So on Mac or Windows, you just have to make sure your Docker desktop is basically is open, is turned on, and on Ubuntu there's ways to set up so that it'll automatically start the daemon every time you reboot your computer, so you don't have to ever worry about it again. So let's see if it downloaded. Let's see. And it's still downloading, so we're going to take a little pause and then come back and give it some more time. Okay, so now it looks like I have downloaded my DMG. So drop into my applications folder, and now I should just be able to open it. There it is. Oh, it's still copying. Oh, it's going to take a bit to copy. And now it's done. Here it is. Oops, not Docker, I meant here. And yes. And yeah, give it access. Give it a password. And you should see this Docker oh, it's going to ask me for a subscription agreement. And now I have my Docker desktop. And Docker is starting. To be honest, I usually don't use this GUI. Like, the most I'll do is look at this thing. So we have to give it a little bit of time to step, I guess. And it looks like it wants me to do this tutorial. I'm actually going to go ahead and skip this, but I think for you it'd probably be worth clicking through it. Right. And now we're going to try this example command. Let's try this example command. And this Docker getting started image, I thought we'd go ahead and try it. That actually took a very short time to download. It might be very small. See, so since I've never pulled it before, I had to go and pull it from the Docker registry. And now I should be able to just go to this on my local host. There it is. And so this is actually a web page that's being generated by this Docker container. So I think I think that's working. So the next part of this is we play with a Hello World program. So Prakhar suggests that we try this BusyBox image. So let's do that. So here he's saying Docker pull. So what that means is that I'm going to go to the Docker registry and pull this image called BusyBox, and it just has a very slimmed down kind of Linux-like operating system in it. It assumes that I want the latest tag. There. So so light. It was just very quick. So then Prakhar says do Docker images. So what Docker images does is it tells you what images you have on your system. Let me make this a little bit cleaner. So you can see I have BusyBox, which I just downloaded. Oh, I downloaded it actually for the first time a few days ago. But at any rate, that's why it was so fast. But at any rate, we have BusyBox on our system, and we also have this getting started image that we played with just a few minutes ago. So those are the images we have. And then we can, let's see, we do Docker run BusyBox. And it does basically nothing. I mean, the one thing you do notice is that it starts up and cuts out very quickly, which is, again, another advantage of using container rather than a virtual machine. But it didn't run anything because we didn't actually give it a command. Like there's no real default command with. So we can, but it does have a Linux-like operating system on it. So let's just issue some command, right? So basically what this does is says like spool up BusyBox and then feed it this command and just execute it inside that container. And sure enough, it spits out hello world. but that was done inside the container. So in principle, let's say you don't have echo on your system, like I don't know, let's say you're on Windows or something. Then what you would do is you could run this BusyBox thing. Now let's try a couple of other useful commands. So there's Docker PS. So if you're Linux-like operating systems, you're familiar with the command Docker or with the command PS. That just basically tells you what containers you have running, right? So right now it looks like my getting started container is still running. Remember we started a few minutes ago, and that's actually kind of something you have to be a little bit careful with Docker, is that it's kind of easy to leave containers running inadvertently, and that eats up resources. So we're going to come back and kill those. But first, there's another command. There's a flag, sorry, for PS, which is -a, and that gives us the all containers, including the ones that are stopped, right? So remember we issued BusyBox a couple of times, so that's there. Those exited successfully. Let's see. So we might want to do like a Docker container prune, and that'll remove all the stop containers. And now, if you go back and do Docker PS-A, you'll see that all we have is this Docker this one. Actually, I want to get rid of that one too, but I need a different one. Docker kill, and I'll kill that container like that. Now we have nothing. Yeah, now that one exited, right? So Docker PS should give us nothing. Excellent. So Docker PS it gives you running as well as an exited container. And so far we've been running batch. So we start a program and let it run, and then maybe it ends and returns, or maybe it just keeps running forever as this other Docker getting started website did. But we can also work interactively, which means that we can be in our terminal on our host computer, in our host operating system, but then actually go inside of our container and play inside there as if it were, a whole guest operating system, which in a sense it kind of is. So the way Prakhar is doing it here is he says Docker run -it, and the -it means interactive, right? And then he has to give it a command, which is sh. That's just a shell command. So it just says open up a sh shell. So I'm going to try that. There, and now we are inside our container. And so I could just say hello, I am in, right? And then when we're done with that, then we want to and the other thing is that looks like Prakhar uses Docker rm command or remove command to get rid of his containers he doesn't want, as opposed to where I used Docker kill. Quite similar. And then he also has this fancy way of getting rid of just the ones that have exited. So you can look at that. And if you think you'll use that a lot, you can keep that in your notes. And now we go on to the next slide. Now let's go through some of the terms in that Prakhar recommends we learn. So first up is images. So Prakhar calls these blueprints for our containers. I guess that's perfectly acceptable. a definition. To I, I would think of this as a single. It's kind of the original copy of the container from which you're going to make copies, because it's already compiled and built. Whereas for me, the real blueprint is a Docker file. Like that to me is terse enough to be called a blueprint. Whereas the actual image is already completely a digital object that's been fully built. But anyway, that's just semantics. Like I said, you'll be fine with that definition there. Containers, on the other hand, those are specific instances of that image. It's basically an image that you pulled from registry, or you built on your computer, and then you started it, you instantiated it, you executed it. Yes, so when you have a running instance on your computer, you're going to call it a container. And the daemon, this is super important. This is a process that's running in the background, and it's managing your containers. So if you're if you're on Linux, you have to be a little bit more careful about making sure your daemon is started. A client, that's an application that takes care of all the user interaction with your Docker with the images. And then lastly, DockerHub. That's really important. That's the primary repository for Docker containers. Again, Docker prefers to call it a registry. It's the same thing. So there are lots of images on there made by lots of different people, and that's one of the strengths of Docker, is that you have a lot of images to start from, so you don't have to start from scratch most of the time. Okay. Next up, we're going to start making some web applications with Docker. And so web apps are actually a big thing with Docker. Like they're not personally the reason I would use Docker. Like to me, for me, Docker is just a container. It's a way to distribute my code in a controlled, isolated environment. But there are a lot of people in the world that like to make web servers this way. And I think it's actually kind of useful to do it even for scientists, because Docker, unfortunately, it does allow GUIs, but it can be a little bit difficult. So this is one way to kind of give a graphical interface to your code, is just to make a web server around it. So Prakar has this static site that he uses for demo. So let's try that. And before we start, we can some of these flags. First of all, there's this --rm. So what that flag means is that he wants the Docker container to be purged as soon as we're done with it. He wants us to run interactively, and then here's the name of his repository and the name of the actual image. And if you've never done this before, then it should pull. And actually, it looks like this is one of this got wiped when my computer goes wiped. So it's going to try to pull it. So let's give it a little bit of time to do that. So you can see it's downloading, and this can, this can take more time this time, because instead of just updating my image, now it has to pull the entire image along with this one does have a few libraries. I think it might have Flask in it, for instance. And now it's done. I spared you a couple of minutes of waiting for this thing to download. And the important thing is this NGINX is running, but we can't actually look at the website that it's generating, because we didn't publish any ports. So let's kill this, and then we're gonna do it again, except this time we need the -p. Let's see. How can we do it? He says -d and -p. -d detaches your terminal, so so that means that you'll get your command prompt back. Let's see, and he also names this image. We can give it whatever name we want, actually. So now it's actually okay. Now it's actually it's actually publishing a website on some port, but -p with no arguments, that just randomly assigns to some available port on your local computer. We don't know which one it is yet. It's actually not like that. It's more like Docker port static site. Yeah. So what we want is this one, port 80, and it says publishing it to port 55001 on my local machine, and so I should be able to see my website on there. So let's go to localhost. And it was port 55001. There you go. And so it's not saying much, but it's a website. And let's go back and see. Yeah, and so he says suggests that you could also specify a port. So here, for instance, he's saying port 80 inside the container is going to be connected to port 8888 on your local machine. So we can try that. And notice that's a lowercase p. Let's see. 8888 is mapped to port 80, and we can get rid of this. Oh yeah, then we need to do like and let's docker kill. Let's kill this one. Oh, sorry, it's prune. And now I should go do, yeah, that should be clean enough. Let's try it again. Okay, this warning should be fine. And now I'm going to go to localhost. Except this time I'm going to try port 8888. Right? And sure enough, there's my website. Okay, and then stop this. Stop status. Docker stop static site. And then here it exited. And we should be able to confirm with Docker PS. It exited. All right. And if we try to look at that website, what's going to happen? Yeah. So that stopped. Now we're going to talk a little bit more about Docker images. And so as we mentioned earlier, there's a command called Docker images. It tells you what images you have available to you on your local computer, images that you've downloaded before. So here we have Prakar's static site image, and Docker's getting started, and then BusyBox, right? But there's so many more. There's a really large number of available images, and so for instance, here's one that's quite useful. If you want this Ubuntu 18.04 LTS operating system to start with, you can pull that, and that should take a little bit of time, but I'm going to spare you the minute or two that it's going to take. And actually, I spared you about 10 seconds. That was actually pretty quick. I must have had it before. That's interesting. Okay, so at any rate, now since you have this, you can run interactively Ubuntu here on your laptop, and I'm going to say interactive, and I'm going to run the sh command. So that should give me a shell, right? So now I'm on an Ubuntu system, and I should be able to say, "Hello, I am Ubuntu," and then I can also use apt and everything else, and get my operating system set up. I can install my software, and then anytime I need this piece of software in this operating system, it'll be there. So let's go ahead and exit, and let's talk about some of these terms that Prakar introduced here. So base image, that's something that it has no parent, so it's something that was made entirely from scratch, and so this is as Prakar says here, it's usually some sort of operating system only. Even things that the Docker registry distributes are usually made from base images. Child images, these are built on base images. So like I say, almost everything that you're going to work with, including your own, are going to be child images. So that means that you copied, that you started with a template, some base image, and then added your libs and compiled your code and so on. So these official images are maintained by the folks at Docker, says Prakar. And so this means that it's not going to be preceded with some with the name of the repository. It's just they're just so basic that they're in a collection that doesn't require you to specify a repo. So for example, these Ubuntu images, the BusyBox, Hello World, there are probably a whole bunch of operating systems in there available. And then there are user images, right? So here, these are the ones that, for example, in your case, you're going to have your user, right? So I'm Samuel Flores on DockerHub. So it'll be Samuel Flores / and then I have things like MMB, Ubuntu, and so on. The image names, right? So here, what we're going to do is going to create our own image. It's going to be a child image, so it's going to be based on Prakar's one of Prakar's images. So he's saying, okay, get all this, get everything you need from this GitHub repo, which is the way a lot of people work, and that's actually how I work. Oops. Okay, so we're going to clone that. And that was actually pretty quick. I mean, the Docker file itself should be pretty light, so I guess that shouldn't surprise me too much. And then we're going to say cd. Okay, and then he's got a Docker file in here. So let's just take a look at that. So a Docker file is, I don't want to confuse you, but this to me is more really the blueprint. Like this is a script which tells Docker how to build an image, right? And as you can see here, this can be quite short. Even like when I distribute MMB, it's actually quite a bit longer than this, but it's still not thousands of lines. It should always be pretty terse. So basically, we said they're base images. So here we're starting from a base image called Python 3.8. So that means that itself probably had a base image that was some operating system, and from the name you would infer that it's got Python on it, version 3.8. This is your default working directory inside the app. So it's going to be like basically issues cd user source app, and it's going to do the rest of the commands in that directory. So here you're going to copy everything that's on your local directory, like basically whatever I'm running in now, right? So all these things. It's going to copy them into the container, right? So your this is another thing. I don't know. I think I didn't mention this, but your one of the nice things about this these containers is that they have access to the directory that they're running in. There's also a bit of downside that they have access as root, but we'll get into that. Let's see. So then run. So these uppercase, these are Docker commands. These are not like Linux commands or something like that. So run, that's a Docker that tells Docker to basically execute this on the command line inside this image. So it's saying pip install this list of requirements, right? So you can look at this list of requirements you want, like oops, sorry, it's this one. Cat read. It's just one requirement, which is Flask. It's a web library, and then it says expose port 5000. So that means that inside the image, it's gonna be it's gonna be putting out web content on port 5000, and then later on we're gonna tell it what port on your local machine to map it to. And then this is the command that's actually going to be executed by default when you run this this image, right? So if you say nothing else, or actually maybe if you do say something else, it'll run Python app.py, right? And again, that app.py is what you just copied from your local directory to build this image right now. Okay, so then we are going to build this. Yeah. So I'm going to use my username here. So my username is Samuel Flores. You can name this something else if you want. You don't have to call it catnip. Let's see. I've actually done this before, so I might have to rename it. So it's reading this Docker file. It's following all the instructions. This might take a couple of minutes, so let's pause. Okay, so that actually did take a few minutes. And as you can see, what it was doing is like basically a lot of it was just downloading this this base image, and then actually getting set up for the specific application, like using pip to install these required libraries. That was basically no big shakes. It didn't take much time. But anyway, now we have it. And now we should just use it. We should just run it. So Docker run this thing. And remember, we have to publish some ports. So let's try. We could just do 8888 like before. And remember that port inside the container was going to be port 5000. So that should work. Let's see. So let's look at port 5000 now. Web browser. Localhost and 5123. No, sorry, I meant 8888. Doesn't seem to be working right. Let's try another port. Actually, let's just do randomly. Let's see, -P. Uppercase P. And we have to run Docker port. Okay, sorry, I need to prune all these old containers. Docker PS, yeah, I just did that offline. But so now there's nothing, and then I won't have any interference with two containers trying to use the same port or something like that. Okay, so now Proctor says map your port 5000 on your container to 8888 on, sorry, 48s on your local computer. And now you should be able to see this catnip thing. And let's see, local host, and we said 8888. And sure enough, you got some GIFs in there with cats. Who doesn't like GIFs of cats? Let's see, so yep. Okay, and so now we've created our first Docker image. And we'll be able to push that onto our repo if we want. So this image that you've created, you can go ahead and put that on your DockerHub repo. If you don't have a DockerHub account, all you have to do is like search for DockerHub, and you should see a link that says sign up for a Docker account. And so and it's free. It should be quite easy. So just do that. And then you have to log in, right? So let's do Docker login. My username is Samuel Flores. Get my password. And that worked. So I have this catnip image here, and I want to push that to my repo. And I actually did this a few days ago, so I'm not sure how it's going to react to my trying to push it again. But anyway, Docker push, it's able to, it parses this to say, oh yeah, I want it to go to my repo. And alrighty, it's pushing. That was quick enough, because as you can see, a lot of these layers already existed. And now, if you go to DockerHub, you should be able to see this in your account. So let's say sign in. Sorry, let me get my password again. And there it is. See, there's my catnip image. And now anyone can use this command to then pull my catnip image. You don't have to use Prakar's image, right? So you should be able to just do like this and replace that with Samuel Flores. And in your case, they would have to pull it first. And then it should be able to just do it. So let's go ahead and do it. And you should be able to see exactly what I'm seeing here. Right, localhost 8888. And there it is. Now it's some different GIF. All right. So again, I feel like what I would recommend doing is, of course, you're required to watch this video and do the reading. But I would strongly recommend actually doing this exercise and getting Docker installed in your system. It's not that much work. If you have a couple hiccups, then this is a great opportunity to have those hiccups, because tomorrow you come into discussion, you'll be able to ask me about them. Alrighty, see you in the discussion.